All right, welcome everyone to my 6.5/9.3 video. Got all of a sudden very paranoid that I was muted or something like this. It's never a fun surprise, to record an entire video and then realize you were muted the entire time. So anyway, so this is going to be my video about 6.5 and 9.3, and I'd like to do a quick recap about these sections. So really, in the ordering of the class, right, we do 9.3 first, which is learning how to deal with these separable differential equations. Which you may have heard my spiel already, like differential equations in general are very nasty, difficult things. And we're kind of dealing with the best case scenario. So one of the nicest situations is where you have a separable differential equation, but actually Math 235 is called differential equations. So you have an entire semester, an entire course dedicated to these things. And that doesn't even, cover everything by any means. So in general, these things are quite nasty, but we're going to be dealing with kind of the nicest case scenario about differential equations. So you learn a little bit about differential equations in 9.3, and then you can apply these to get some nice formulas and whatnot in 6.5. But if you kind of just look at 6.5 on its own, and you're not like developing the equations there, which again, we do with a 9.3 stuff, then really there's no calculus in 6.5. There's no derivatives, there's no integrals, there's no anything like that, right? All of the differential equation stuff is really housed in 9.3, and we're doing that. And 6.5 is really just a bunch of application problems. And so I don't really have anything more that I really want to say, I guess, about 6.5. I think it's pretty well covered by the pre-class videos and my in-class stuff from last semester. And so I'm not going to do a new problem about 6.5. Historically, when we've seen 6.5 show up on quizzes and exams and whatnot, they're kind of smaller problems, maybe multiple choice or true false or things like this, but they're not usually going into too much detail, I suppose. And so I'd really like to focus our energy, our effort on 9.3 instead. And so that's kind of my quick recap about all this. And so with that, I'd like us to go ahead and take a look at this example. Unfortunately, I have misplaced my Apple Pencil. I have no idea. I've ordered a replacement and whatnot. So this is going to be a slightly different style of video than I usually do, that I like to do. And so please do bear with me. Again, at this point, I would recommend that you pause the video, that you try this problem out on your own, see how far you can get, then come back, unpause the video, hear me explain a little bit, and again, try to make this a more interactive experience rather than just a passive experience. So, okay, please try this problem and then come back and see what the results are. Okay, so yes, like I mentioned, I misplaced my stylus and whatnot. And so I've kind of worked out a filled out solution here that I'm going to talk through. So I have a solution kind of written down, and I'll talk through the ideas and how we jump from line to line. So that's going to be the style of this video. And again, my stylus should be coming on Sunday. So I'm hoping that I'll be able to go back to kind of the normal style of my video for future times. But who knows? If you like this style, please let me know. I'd be interested to see, kind of where the split is. I know that different students learn in different ways. And so maybe there's some of you out here that actually like this more. Okay. So the first thing, right, when we see these differential equations, sometimes they're written as dy dx, sometimes they're written as y prime, right, just different notations for the same thing, the derivative of y with respect to x. So I like to, especially for these separable differential equations, I like to write dy dx because eventually we are going to be separating the y's and the x's here and kind of treating this more as a fraction of differentials rather than just a derivative here. And so I think having it in this notation makes a lot of sense. The other key thing that you learned in 9.3 is that whenever you have a separable differential equation, you have to be able to separate it. That is writing it as a function of just x's times a function of just y's. And so this one is a little bit complicated, right? Again, I'm choosing kind of the problems here for these asynchronous videos that are on the upper end of the spectrum. And so separating this one into just y's times just x's is a little bit tricky, and it relies on something from our algebra days called factoring by grouping. So we're going to go ahead and factor this by kind of grouping things. And so you'll notice that if I look at just these first two terms here, that they have in common a y. So I'm going to go ahead and factor out a y, and that's what I do right here. And then for the second two terms, we have negative 4x minus 6. Those have in common a negative 2. So I'm going to go ahead and factor that out here. And when I do that, you notice that from both of these groupings, right, the thing that's left over is 2x plus 3. And so now we can go ahead and factor out this 2x plus 3, and we're going to have left over, well, from our first term, a y, from our second term, a minus 2, and that's going to be multiplied by 2x plus 3. Of course, it's probably been a little while since you've done factoring by grouping. I would be paranoid here, right? That maybe you've made some mistake that you don't remember how it's quite working. And so double check, right? If you FOIL this all out, the first, the inners, the outers, the last, right? Do you get back to where you started? And the answer is going to be yes. So thankfully, we are doing things in the correct way. Okay. Now we're going to go ahead and do the separating, right? So I mentioned that whenever we have a separable differential equation, you're going to be separating at some point, right? So I'm going to gather all of the y's on the left-hand side. So you can see that I divided by this y minus 2, and all of the x's on the right-hand side. So I multiplied through by this dx. Again, you want to have these dy's and dx's in the numerator, right? Because we're going to be using these as our differentials that we're going to be integrating with respect to. And so do make sure, right, that the dy should stay on the left-hand side because it's already in the numerator. The dx should move over to the right-hand side so that way it can be in the numerator there. Okay, now we're going to be integrating. So we go ahead and integrate on both sides. When I integrate my 2x plus 3, I get x squared plus 3x plus c. And when I integrate 1 over, remember you get this absolute value of the natural log. Sorry, I said that in the wrong order. The natural log of the absolute value of, and in this case, y minus 2. Of course, you can double check, right? Take the derivative and see that you get back to where you started. So these are indeed good antiderivatives. Now we're going to go ahead and solve for y. So I'm going to go ahead and apply an e to both sides. The e will cancel out this natural log. And then I'm going to add 2. So I go ahead and I add 2 here. And again, we are trying to find a solution to this differential equation where we have y of 0 is equal to 0. So I'm going to go ahead and I'm going to try to plug in 0 for x and 0 for y and find a c value that works with this. So I plug in 0 for y over here, right? This is my y. So I plug in a 0 here. I plug in a 0 everywhere I see an x. And I'm trying to find this c value that makes this true. And so now we do a little bit of algebra. We rearrange things. We take a natural log on both sides to cancel out this e, and we get c equals the natural log of negative 2. And so you can plug this into your calculator, or maybe you already see the issue here, right? Natural logs, you can't plug negatives into them. There is no c value that makes this true. And so this is not actually a correct solution, surprise. But I'd like you to go ahead maybe at this point to pause the video again and ask yourself, right, what happened? Where did we go wrong? Somewhere in here, I made a mistake. And I would like you to be able to try to identify, right, where did I make that mistake? All right, so again, pause the video, think about that, and then you can unpause it. And then I have the real solution also written out. Okay, so the real solution I put on the second page. So yeah, real solution. So the big thing here, the mistake that I made is, actually, we'll go back up here really fast, is, right, where did my absolute value go, right? So I applied an e to get rid of this natural log, and notice that I just took away the absolute value. And it's one of these things that in math, like you kind of, if you're doing a little bit nicer problems, right, you do end up on this positive arm of the function. And so it's kind of like when you take square roots on both sides, right? Students kind of know that there's like a 90 or 95% chance, maybe as high as like 98% chance that you want the positive answer instead of the negative answer. And so sometimes, right, we just kind of go too fast and we ignore the negative bit. And so that's essentially what's happening here, is that because I've just gotten rid of this absolute value signs, I've actually lost something. And it turns out that I want to be on this negative arm of this curve here. And so let me kind of explain a little bit more and show you the correct thing. So again, when I apply an e on both sides, this doesn't actually get rid of the absolute value. The absolute value should still be here. And right, whenever you have the absolute value of something, either what you're plugging into it could be already positive, in which case nothing happens, or you could actually be plugging in the negative, right? And so we want to make sure that this thing right here is actually equal to this absolute value. So again, either it could be this y minus 2 could be equal to the positive or the negative, because again, when you plug it into the absolute value, right, whether it's plus or minus, that's going to go away. And so there's actually two arms to this curve, as I've been saying, right? There's a positive one and there's a negative one. And so as we saw, I guess we could still solve for y here. And again, I'm just going to leave this plus minus for the time being. So now when we go and we try to solve for the c value, notice that we consider both of these as possibilities. So we have the positive stuff over here. So we have 2 plus, right? But we also need to consider the 2 minus. So the 2 plus, as we saw, does not actually have any solutions. And so that's where that one just kind of fizzles out, right? There's no solutions. That's the end of the story for that one, right? However, over here with the minus, when we rearrange and we take the logarithm on both sides, right, we are actually taking the logarithm of a positive value, right, of 2. And so c here is the natural log of 2. And so, like I said, there's only a solution when we choose the negative branch of this curve or the negative arm of this curve, whatever phrase you'd like to say here. But again, we need to choose the negative. The positive doesn't have any solutions. And so we have to choose the negative one here. And so this means that we know what our function is that actually goes through this point. Again, we were trying to find a c value that we actually obtain y of 0 equals 0. So when c is equal to the natural log of 2, that works. So again, everywhere I see a c, I'm just going to be plugging in the natural log of 2 here. And again, my overall goal, pretending that this is like a D2L quiz or exam problem, right? I'd like some number that I can input into D2L, and I'm going to round this to 3 decimal places, similar to a quiz or an exam. And so in order to get a number, maybe we ask to be plugged in something, right? So I'm going to ask you to plug in 1, right, to see if you have the right function or not. So y of 1, when I plug in 1 here, well, 1 squared plus 3 times 1 plus this natural log of 2, we need to take that and subtract it off of 2. And so when you do this, you can verify in your TI-30 calculator or your favorite approved calculator, right, that you do get a very negative answer, negative 107.196 once you've done your rounding. All right, so again, this is certainly on the upper end of the spectrum. I may have gone a little bit overboard with this, but I feel like it is sometimes glanced over. I know that certainly there's been times in classes where I just glance this over because this is complicated. So this would certainly be on the upper end of the spectrum, if we did choose something that was on this negative branch or this negative arm for our solution curve here. And this is one of these things that, I would say that if you did see a problem that was this difficult on the quiz or the exam, right? We're expecting to probably award a decent amount of partial credit for anyone who, makes this mistake and just chooses the positive branch. And so that's where kind of some of this partial credit stuff certainly comes in useful. All right, so I hope you learned something from here. I hope you enjoyed the video. Again, I'm sorry that this wasn't in my normal style, but please let me know how you like this video or not. Either you can do the comments in YouTube or you can post in Piazza. I'll take a look at either one of those. Thanks so much for watching. Have a good weekend.